Hi everybody, so this video is to do the last page of the guided notes that we did not get to in class, and it is talking about something called the discriminant. Now the discriminant is part of the quadratic formula, so what I'm going to do to start is at the top of the page I am going to write the quadratic formula so we can have it in front of us. So here we go. Quadratic formula is x equals negative b plus or minus square root b squared minus 4ac all over 2a. Well, that's the Frere-Jacques version. Of course, we did the Pagos-Liesel version. So the discriminant is the stuff that is underneath the radical in the quadratic formula, the b squared minus 4ac part, not the square root itself, just the stuff that's underneath it. And the value of that number that you simplify underneath the square root can tell you stuff about what kinds of roots or solutions or answers you had to the quadratic equation. Now, when you're looking at a quadratic equation, there are four possibilities for the types of roots you have. There are four possibilities for the discriminant's value. So the first is the number you get underneath is a perfect square. Sorry, is positive. Meaning you can take the square root of it and get a real number, and it's a perfect square, meaning when you take the square root goes away. So when that happens, this will be a nice, pretty rational number. So then when you're doing the quadratic formula overall, you're adding and subtracting a nice, pretty rational number. So you're gonna get two separate numbers that are both pretty and rational. So when this is the case, you have two real, rational roots or answers or solutions. Now, this means that the original quadratic was factorable, because only things that give you rational roots are actually factorable with regular real numbers. Now, what if your discriminant is positive, but it's not a perfect square? Well, if you look back up here at the quadratic formula, if it's not a perfect square, you're still going to get a square root of a number. It's going to be real, but it's going to be one of those irrational numbers. The decimals go on forever. So you're still going to be adding and subtracting a number, so you're going to get two separate numbers, but the answer is going to be irrational. It's not going to be pretty. And so if you tried to convert that in your calculator to a fraction, it wouldn't work. So when you have this, you're going to get two real, irrational roots. And if the roots are irrational of a quadratic function, the original problem was not factorable. Now, what if the discriminant, having a hard time with that, equaled 0? Well, we had an example in the activity that we did that actually happened that way. If the thing underneath the radical equals 0, then you're taking the square root of 0, which is 0, and then you're adding and subtracting 0, which gives you the same number. So in this case, you're only going to get one answer. I mean, technically it's two answers, but it's repeated, and it's going to be pretty and rational. So this would be 1, that says 1, real, rational root. And again, anytime the root was rational, the original quadratic was factorable. Now, what if the thing underneath the radical is negative? Now, in Algebra 1, you probably ran into this, and that would cause you to take the square root of a negative number, and a square root of a negative number, as you were taught back then, is not real. So one thing we could say is there are no real roots here, because we'd be taking the square root of a negative number. However, and this is where Algebra 2 is different than Algebra 1, we are going to talk about the fact that there are answers that work, but they're not real. So this category will end up giving us two imaginary roots, and we'll talk about imaginary numbers next time. Two imaginary roots. The imaginary roots always involve taking the square root of a negative number. So this also means the quadratic is not factorable. Now, why am I making all this big deal about factorization? Well, sometimes when you're trying to factor a quadratic and you're having trouble finding the numbers that work in it, you can always do the discriminant, not the whole entire quadratic formula because that takes too long, but you can do the discriminant, the quick b squared minus 4ac, and see if it's either 0 or a perfect square. And if it is, the thing factors somehow. You just need to keep looking. And if it doesn't factor, and you can stop looking. So let's look really quickly at the bottom here and do these two problems. So the question says, tell how many solutions each quadratic equation has and of what type. And you absolutely do not need to tell me what those solutions are. So to do this, I'm going to find the discriminant. So that's b squared minus 4ac. And in this case, my b is negative 12. My a is 4. And my c is 9. So if I do this simplification, negative 12 squared is 144. Minus 4 times 4 times 9 is also 144. So this gives me 0. So that means my discriminant is 0, so I'm going to have one real rational root. Now, that means this quadratic, if I had solved this by factoring, it would have factored, and it would have factored into two of the same factor. In fact, those factors would have been 2x minus 3 and 2x minus 3. So let's look at the second one. Again, we're looking at the discriminant, b squared minus 4ac. My b is 7 here, minus 4 times a, which is negative 3, times c, which is negative 6. 7 squared is 49, and we have minus 4 times negative 3 is negative 12, times negative 6 is 72. So we have 49 minus 72, and I believe that's negative 23. This is less than 0, so that means I'm going to be taking the square root of a negative number, which normally would say no real roots, but it also means there are two imaginary roots. And again, we'll talk more about those imaginary roots next time in class.